Hello, everyone. I'm pleased to welcome you on the web seminar. We are here in Chicago on the WRI. Fortunately, you're not able to be here. However, I've prepared here a presentation for you, which you can now watch over the webinar. We are talking today about high-performance rail milling technology for North America. Before we talk about the technology, would like to tell you a little bit about our company. Our company's company Linsinger. We are located in between Salzburg and Linz in Austria, as you see here on the picture. Among the rail business, we are also dealing with other businesses as well, like sewing technology, milling technology. We offer service and tools and offer rail service as well. On the picture below, you can see various branches where we are. So the tube mill industry, forging industry, rail processing industry, automotive, shipbuilding, and non-ferrous industry. The company was founded in 1946 and has currently around 500 employees. So I would like straight jump into the rail technology bit, but before we talk about the rail milling technology, let's talk about defects, or let's talk about issues our customers have in the network. On the picture here on the left side, okay, you can see various rail profiles which can occur in the network, starting from A as a standard profile and B to P, various one profiles which can occur, of course, and influence the network in lifetime. And all other defects as well, like you see wheel burns, squats, head checks, inundations, and bell gross piece. There are all kind of various defects which can occur, and of course reduce the lifetime of the network. One of the biggest issues currently are head checks. Head checks, what you see here in the center of the screen, kind of grow slowly in the rail, and after certain million gross tons, it kind of decided which direction it goes. Okay, it can go quite deep into the rail, and of course reduce lifetime. So here we have some pictures of head checks. Basically, previously it was just possible to see these head checks on visually, okay. But due to the new current ultrasonic technology, you are now able to locate these defects and see in millimeter exact how deep they are. So what is rail milling all about, especially the Linsinger rail milling technology? I do understand that there are various rail milling machines out there in the market, and everybody's working a little bit differently. The Linsinger rail milling technology is working with a cutter head, okay, with cutter head, and you have a grinding disc or polishing disc, which removes the milling pattern. And both units work in circumference direction. So the arrangement of a milling machine is that you have 1, 2, sometimes also 3, up to 3, 4 milling units per side, okay, and then you have a grinding unit which removes the milling pattern, and everything happens in one working pass. So here we have again a cutter head. The cutter head is equipped with carbide tips, okay? So in the profile, or in the cutter head itself, the profile is integrated. So that means if a customer wants a special profile, whatever it is, 61, 62, it's designed in the cutter head, okay? And the carbide tips is a standard tool, and these carbide tips can be used up to 8 times. Okay, you just flip one side over and over. So the lifetime of one carbide edge can be approximately 2 km, sometimes even 3, 4. It depends on the condition of the rail. Then you have also the grinding wheel, okay, or polishing wheel, which just remove the milling pattern. That you have a smooth surface. So what are the advantages of the milling technology? So you have dry processing, no coolant agent necessary. That means you don't need any water to carry with you. Okay, you have high surface quality with low roughness, below 7 micrometers. Material removal from 0.3 up to 5 mil per working pass. So actually, the operator removes only the necessary material which is nearly required to be removed. So if, let's say, from the customer side, it says you have to remove 2 millimeter, the operator just press in 2 millimeter and then the work is done. You have high accuracy at the longitudinal profile, high accuracy at the transverse profile, low cost per completed meter of track. The reason why? So if you have, you do not need to do several passes. So compared to conventional grinding in various areas where you have to remove, let's say 2, 3, 4 mil, let's say. So with a grinding train, you would need several passes, 20, 30, whatever. With a milling train, this can be done in only one working pass. Smooth processing with a change of metallurgical structure, okay? When you do milling, all the heat goes into the metal chips and does not remain in the rail. So we are not changing the metallurgical structure of the rail. And another huge benefit, no sparks and no fire hazard. So that means even in tunnels or in hot areas, there is no issue with sparks and fire. Environmental friendly, so actually you collect all the swarf with you. So over 99% of metal chips are collected and can be sold then afterwards as scrap. Switches and crossings. With this machine, all the switches and crossing can be done within 45 to 60 minutes and also in one working pass. This is also possible with this machine. So just to show you a little bit what is the power of the machine. Okay, here you see some lipping. Okay, the lipping you can see on this picture here. This is the red line here. So this rail has been reprofiled in only one working pass. So whereby the milling machine was with two milling units per side. So the first milling unit removed the lipping, okay, and the second milling unit reshaped the profile. And this happened all in one working pass. And our machine and the Linsinger machine can also has an integrated measuring system, so it can measure the results of the rail milling process. Here we have some very interesting. Here we have done some very interesting tests. Okay, so we got some rails from the UK. And we were trying to prove if these eddy current systems are correct. So what happened was we got this rail and we reprofiled this rail with a stationary rail milling machine. Okay, and we wanted to see how deep the cracks can grow and if the measuring equipment the ultrasonic equipment is correct. So what we have done, we have removed pass by pass. So first pass, second pass, third pass, and fourth pass. And you could have seen, and you could seen how many passes were required to remove the defect, and see even with the fourth millimeter how the crack can grow in the rail without noticing. Okay, and the target is to remove these cracks. This is a potential defect and can cause a train derailment. Another interesting test we have done, one of our customers in the UK. So actually they've gave us one really bad rail to reprofile. You can see it here. That was in Liverpool Street. Okay, you can see how the rail looked like. So on this side we measured the rail before, and it looked like kind of a mushroom. So even this rail could be reprofiled. So this test has been done with a smaller machine. Okay, so the first pass we were just removing the lipping. Okay, And after the second, third, and the fourth pass, we were able to remove all defects, all cracks removed, rail reprofiled, softness, roughness below 3 micrometers. So it took them 5 passes to do it with a smaller milling train. However, with a bigger milling train, okay, this would be able to be reprofiled in only 1 working pass. So what has been done? Okay, so we removed here 7.3 millimeter on the gauge corner, and on the center of the rail, removed just 2 millimeter. Okay, so if you take a wear rate per year of approximately 0.28 millimeter, okay, so you can gain out of a rail which you normally need to scrap 14.6 years of rail life. So this is a huge cost saving. Okay, so in here we have done some comparison. Okay, in Liverpool Street and also in Warrington. So the customer, it cost them £47,000 to mill a rail, comparing with £900,000 for re-railing costs. So this is a huge cost benefit. The same has been done in Warrington with £57,000 in 2 shifts, comparing with £1 million re-railing costs. So this is a huge cost benefit. It's possible to save quite a lot of money in areas where you normally need to re-rail, and so with milling you are able to avoid re-railing for several years. And here I was preparing some drawings just to explain what is possible to do with milling. Okay, even the picture here, what you see here, if the rail height is still there, okay, so that even if you remove all these defects, the railhead is still has the limits that you don't need to re-rail. You also can reprofile these rails as well. Okay, and here on the left picture you can also see possibilities. So let's say you have here such a heavy wear. Okay, even this rail you can reprofile if it doesn't matter that this material is missing on this side. So even here you could reprofile. It's really depending what the customer wants. Another possibility as well, let's say there's a possibility as well to switch rails to switch rail from left to right, for example. Okay, and you would be able here as well to use the other side of the rail where you could gain more rail life. But of course, what you have to do, you have to cut the rail and put it on, and flip it over from one side to another side. So what are the achieved targets with the milling? So you can increase the life cycle of the rail. I put here 300%, but it could be much more than this. High standard at the longitude and transverse profile, a reduction of wear, of course, if you have always the right wheel and rail conicity. You improve the wheel rail geometry, reduction of maintenance costs and life cycle costs, and of course travel noise. You reduce travel noise and increase travel comfort and safety. And of course, if you have very good rails in combination with wheels, there are benefits of energy and fuel consumption. So currently we have over 65 rail milling machines worldwide. So this is not just it's not new technology. This technology is since years now in the market. And here you can see our fleet. So actually we have here the bigger machines starting from MG31, which is 3 milling units and 1 grinding unit per side. Then we have the S06, S03. The top 3 are mainly for the big railways, class 1s, and where you have to remove more material. And here below you have smaller machines, which are an S02 railroad truck or MG11, where it is not necessary to remove so much material, and these machines are designed for transits and metros, especially with the smaller structure gauges. And we also offer stationary machines as well. So if you, for example, have rails in the shop where it needs to be reprofiled, this can be done with these milling machines. Thank you very much. I got to the end to my presentation. I'm happy to get some Q&As. You can send me also emails as well. Thank you and